Hello everybody, nice to see you, and thank you very much for waiting as we started this live stream. I was in the middle of doing some of the work that we were doing with Novid to try to stop the spread of COVID-19. Actually, I'm very happy to say the reason that I was busy is because we actually just made a technical breakthrough where we're able to detect whether or not people are nearby with an accuracy that's much better than the methods that were being used before, like using Bluetooth. So that was exciting, and in fact, if you go to the front page of my university, which is Carnegie Mellon University, if you go to www.cmu.edu right now, you'll be able to see what we've been up to. It's actually on the front page of the university. So, okay. Well, let's see. Let's start to talk about what kind of questions that we have today. First of all, thank you all for joining us on this last weekday of the week. And if you're new, I'm going to tell you you're in for something that's different from what you might have been expecting. We don't do something like a usual class because you already have a class. You already have good teachers. I'm trying to show you something that might be different. And what do I mean by different? Well, I don't know. It depends on what you ask. And so I will use whatever I see in the chat to improvise some interesting math and maybe even some science topics, which hopefully will be understandable to people who are doing algebra or geometry. So let's begin. What do we see here? Well, here's a question. I can read part of the question. Can you show us how to methodically solve problems that are not intuitive? Vipin Bhatt. Oh, how to methodically solve a problem that's not intuitive. Those are the fun questions. The questions that you already know how to do are not very interesting because you already know how to do them. But if there's something that you don't know, if you don't have the intuition for, you just start chipping away at the different sides of the problem. You go and say, is there some smaller piece of this problem that I can try to solve? Is there like a special case? What if it's a problem about n? What if n is 1? What if n is 2? Can I try to understand? Actually, if you look at the live stream that I do before this on Mondays, Wednesdays, and Fridays, that's my live stream for the people who are taking my PhD level class here at Carnegie Mellon. And the way that we do everything is we say, let's think about a hard question. And what would be the answer if n equals 1 or if n equals 2? Or what are the small cases? Can we find a pattern? And as you do that, you'll find something. And that's also related to what I've been doing on Novid, which is the app to try to stop the spread of COVID-19. Basically, we need to solve a big problem. Can we break it into small problems? Can we solve each of those little ones? And as you do, and each piece of the puzzle comes together, then eventually you solve a big problem. Other questions. What can we have here? Someone's late. What's the question? Well, that's what I'm trying to figure out right now. Wow. Now here comes a question that looks like math. I don't even know what the whole question is. We'll see. So let me see. Well, this looks kind of long and complicated. So let me start reading from the top. This is by Aaron Peng. And it says, all right, there are 10 bins. And the bins are numbered from 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A cat smacks 2 balls into them and has a 75% chance to use the right paw, which has a 25% chance of landing in bins 1, 2, 3, 4, 5. And vice versa for the left. What's the probability of an odd bin sum? Oh wow. Okay, let me try to summarize the question because this is a bit of a long question. So what do we see here? We see that there's a cat. That's the important part. The question has a cat, and the cat has 2 paws. One paw is the right paw, and one's the left paw. And there are also 10 bins from 1 to 10. So there are 10 bins, which are numbered from 1, 2, all the way to 10. Okay. Now, the cat's going to smack 2 balls into them, and there's a 75% chance to use the right paw to smack, which has 25%. I actually don't even think the question is done yet. There's a 75% chance to use the right paw, and that has a 25% chance. I understand. So, I still feel the question isn't completely specified, but let's just try. All right? So the cat has 2 paws, and on the right paw, you're saying that, to be perfectly honest, actually, I don't see that the question is well formed. So I'm going to go and make my own. I'm going to make my own problem out of this because I unfortunately don't see the question as well stated. So it's like somehow there's some chance that you use your right paw to do something because we're saying that the cat has 2 paws and is doing something, and we want to know about what's the probability that the 2 balls get into bins with odd sum. But we need to be more specific. So you're sort of saying that with the right paw, what happens is that I'm going to say there's a certain chance that you land in bins 1 to 5. Let me make the numbers easier. With the right paw, there is 75% chance of putting ball into bins 1 to 5, and 25% chance of putting ball into bins 6 through 10. That's what happens with the right paw. And I'm basically making up my own version of the question for you, because the one that was stated I don't quite understand, but I can make one that's still an interesting math problem to talk about. And the left paw, you're saying it's vice versa, which is 25% chance of putting ball into bins 1 to 5, and 75% chance of putting bins into ball into bins 6 to 10. And the question is, what's the chance that the sum of the bin numbers is odd? Let's do that. What is the probability that the sum of the numbers, bin numbers, is odd? Okay, I like this question because when you look at the question here, it looks like it's very complicated. I mean, there's 10 bins, there's a cat, cats are unpredictable, and this cat is somehow, there's 2 paws, and one paw has a 75% chance of dropping into bins 1 to 5, and then a 25% chance of going the other way, bins 6 to 10, and then the left paw, is this left for you? It's my left hand. Okay, so the left paw is going to have a 25% chance of going into the first bins and a 75% chance of going into the last bins. Now, what's the chance that it's odd? So whenever you look at this, it's too busy. It's too busy of a question. There are numbers from 1 to 10. It's going to be horrible. Except that the good news is I only asked the question about odd. And if I only care about the answer of even or odd, then you go back up here and you say, you know, I think what I'm going to do is in this white section, which is the right paw, let's just figure out the probability that I get even or I get odd. Okay? So I'm actually going to show you how to do this problem. This problem is not as hard as it looks. I'm using the white color because I'm going to talk about the white section. In this white section, oh, that's not white. Now this is white. In this white section, I first want to know, what's the chance that I get an odd bin number? And what's the chance that I get an even bin number? This is all I actually need to know out of the first part. Maybe some of you can help me do this problem. And I promise you, even if you're only taking Algebra 1, just stick with me and listen on this, because it's not really that hard. Okay? So this is honestly not really that hard. I have a 75% chance to go and get one of these bins 1 to 5, and I have a 25% chance of going into the other half. And I want to first know, how likely can I get an odd bin? Well, there's 2 ways to get the odd bin. One way to get the odd bin is first to use the 75% chance of getting the ball in bins 1 to 5. And after that, if I got 75% chance of getting into bins 1 to 5, what's the chance that I'm odd? Well, if I'm already going into bins 1 to 5, how many of them are odd? 3 of them are odd. 1, 3, and 5. 75% times 3 over 5 plus, and then there's a 25% chance that I get into bins 6 through 10. But if I get into bins 6 through 10, the chance that I get an odd bin here is, well, the odd numbers are 7 and 9. What's this? Not 3 fingers. 7 and 9. So there's 2 choices out of 5. I claim that is the probability that you get an odd numbered bin with the right paw. Does everyone understand this? I want to double check that this makes sense to people, because it's not something that requires really advanced math. It's just a way of saying, look, I've got a right paw. 75% chance something happens, 25% chance something happens. If I go the 75% way, then I'm already going into bins 1 through 5. Which of them are odd? 1, 3, 5. 3 good options out of 5 options. So this first part is getting into the bins 1 through 5. The second part comes from get into bins 6 through 10. Well, there's a 25% chance I take that fork in the road. And then once I take that fork in the road, there's a 2/5 chance that I get 7 or 9. The question is about Schrodinger's cat, apparently. Well, it's about a cat. The question is right here. You've got a cat. The cat has a right paw. 75% chance that the right paw reaches towards bins 1 through 5. There are 10 bins, and just like picks one of them and drops a ball in. Or 25% chance that the cat reaches to bins 6 through 10 and drops a ball in. And then the same thing is going to happen with the left paw. So now let's see how this works. First of all, what is this? Let's calculate this. You'll notice that I did something that looks horrible. I have both percents and fractions in the same thing. But that's okay. A percent is just, it's something over 100. And in this particular case, I'm going to go and just multiply 3/5 by 75 because 75 is divisible by 5. 75 divided by 5 is 15. And so the top part is 45% plus 25 is divisible by 5. The result is 5. 5 times 2 is 10. 45% plus 10%. So I have a 55% chance of getting into an odd bin. So I'm saying that somehow the cat smashed the like button. Well, the cat is smashing a ball into one of these bins. And so the cat smashes the first, with the right hand, smashes a ball into an odd bin with probability exactly 55%. So can someone else tell me the answer to, then what is the probability that with the right paw, that the cat gets an even bin? Does anyone know this? If it's 55% chance that the cat gets an odd bin, what's the chance that with the same paw, the cat gets an even bin? What do you think? I'm going to take a sip of water while you think. Great. Great, I see the answers. Because it's either getting an even or an odd, right? So if it's 55% chance of an odd, then it's 100% minus that. 45% chance of an even. This is good. We've gotten a large piece of this puzzle done. How about here? Well, now let's look at the left paw. What's the deal with the left paw? With the left paw, I need to do the same thing again, right? I want to know what's the chance that the left paw gets the ball into an odd bin. Because later I'm going to use these things together to figure out the probability that the sum of the bins is an odd number. Okay? So let's go ahead and do this. What's the chance that I get an odd bin? Well, first of all, there's a 25% chance. I won't write the word bin because I don't have enough space. My head is here. So the odd bin, there's a 25% chance of getting over to there, to the 1 to 5, times, there's 3 odd numbers between 1 and 5, 1, 3, and 5. So 3 over 5, plus 75% chance of getting into bins 6 through 10. And 6 through 10, there's 2 of those that are odd, 7 and 9, times 2 over 5. And this looks familiar. Well, okay, I say it looks familiar, but maybe let me pause on that. Let me not say it looks familiar yet. You will soon see why it looks familiar. Let's try to multiply these, okay? If I do the same multiplication I did before, 25 divided by 5 is 5, so I get 15%. Plus, the 75 divided by 5 is 15. 15 times 2 is 30. Okay, so the chance of getting into an odd bin is 45%. Wow, that's kind of neat. That's like the same thing as that one. Is there a good reason why they are? Like the cat's right paw has a 45% chance of getting into an even bin. And then now we found out the cat's left paw has the same chance of getting into an odd bin. Why would that be? Why would it be the same? And I'm telling you, I knew it would be the same. Yes, they are reversed. Thank you. That's very sharp. Because actually what happened, if I look at the right hand and the left hand, all that's going on is that somehow the right hand was 75 versus 25 of getting towards the small numbered bins versus the big ones. And the second paw was just the other way around. So it's sort of like whatever chance you had of getting in your right ball into a bin over here versus over there is like your left paw getting into there versus over here. Right? What I'm trying to say here is that if you just reversed the left and the right, actually, that's all that seems to be going on here. So Okay, so this is kind of nifty. This means that we actually don't need to do as much calculation actually if we looked at this question, because you see we have it's 25 versus 75 in both situations, and the only thing that was relevant was somehow with the 75% chance, that was where you got the three options, and then over here the 25% chance you have the three options. Maybe another way of thinking of it is that maybe you could say, let's just talk about the right paw and then take all of these numbers and take 10 minus them. Sorry, 11 minus them. Another way to see this symmetry is if I said, hey, let's make a model for the left paw by saying what you do is you do the right paw thing, and whatever number you get, you take 11 minus that number. If you did that, then if you got to these 1 through 5, the 11 minus those numbers would be the 6 through 10, which are those. So if that made sense to you, that's cool. If it didn't make sense, don't worry. We don't actually really need that here. But I just wanted to tell you, there's a way to see right away that it should just be flipped. Okay, let's finish this. If the odd percent chance is 45%, then the even with this left paw is going to be 100% minus that, which is 55%. Now let's finish. What's the probability that the sum of the two numbers is odd? If you want to get a sum of two numbers to be odd, you need to have odd plus even or even plus odd, right? So if I want to do this piece, I need to know, first of all, what's the chance that I get an odd plus an even? The way you get odd first and then even next is odd happens with probability 55%. I'm going to already write them as decimals. 0.55 times, and then over here I have to get an even. Even is 0.55. And I also need to know what's the chance that I get an even first and then an odd. And to get an even first, that's a 45% chance. I see people are already getting the answer, which is cool. Times. And I need to know the chance of getting an odd over here. That's a 45% chance. Now I need to multiply and add. The good thing is there's a nice trick for multiplying numbers that end in 5. I don't have time to talk about all of that detail here today. That actually also happens to be in our normal daily challenge online courses. If I do this, 55 times 55, I do 5 times 6, which is 30. And I write a 25. 0 point. And 4 times 5 is 20. That's 0.2025. If you don't believe these, you can also look it up with a calculator. It will work too. Oh no, did I get the wrong answer then? Because if I add these two together, I get something which is barely over 50%. I get like 50.5%. I might have a mistake. Ooh, so is there a mistake? Let's try to see. If people actually legitimately see that there's a mistake here, please do tell me where the mistake is, because that does tend to happen. That's not my strongest piece. But indeed, it looks like we agree with this. And let's add them together. If I add them together, I get 0.505. What a nice number. That is equal to 50.5%. So I think we've solved your problem, your cat problem. I think we've solved your cat problem. Let's say it this way. So I think we've solved your cat problem. But there's something else I like to do whenever I see the answer. It's like, does it make sense? Should it be close to half? What do you think? Do you think that if a cat is randomly like putting balls in, should it be like roughly half chance that the sum is odd? Well, yes, because it's either going to be odd or even, right? And if you have lots of bins, then it will actually be more likely that it's going to be close to half. Because somehow the more bins there are, the more spread out everything becomes. So, okay, that looks like that's the answer to your question. Somebody else has commented, looks like we spent 20 minutes on it. Well, yes, we did. And the reason we did is because I was hoping to use this to make like a mini lesson on how to do all kinds of things. You know, some calculations of probabilities, some observations of evenness and oddness that save us time, and also maybe a few comments about how you compute multiplications and how you do these too. Let's see. What other questions do we have here? Let's see. Okay, I did see a question by Andrew Chow. Can you talk about how games generate biomes? That's quite interesting. So in some of the games that you play, there's like a virtual world, and somehow some of these games have a huge virtual world. And sometimes the virtual world is completely generated automatically. You might wonder how that's done. Well, of course it's done using math. You see, the first thing that probably needs to be done is to go and figure out what's the level of the terrain. And to do that, you probably use some kind of random numbers where you start flat and maybe you just start to add some mountains here and there. And that makes it look more realistic. Actually, a lot of things that happen in nature are also fractal-like. And so I wouldn't be surprised if the way that things are going on in the leaves or in the ferns inside the games you're playing is also to do something like that. But then after that, you need to have some probabilities. This is where probability is so important, where you go and say, well, with some probability over here in this area, there's going to be like trees, or with some probability over here, there's going to be a lake, or over here, there's some probability of bad people or bad things, whatever they are, like whatever the evil creatures are that you're supposed to fight. But the point is that there are always these what they call like spawn probabilities, which is like the probability that there's going to be something that spawns there. And ultimately, what the game creator needs to do is they need to think about how to put the probabilities across the whole system so that when they press the button to generate the world looks as realistic as you can. I actually thought this was an interesting thing myself too. Like when I was in high school, some of you know I wrote a computer game. I wrote a bunch of computer games. And because I didn't have the time to design levels for the games, I even made a random level generator. And if you want to make a random level generator, you need to think like, what will I do with the backgrounds? Can I come up with some kind of a pattern or some kind of a rule where if a river starts, will the river continue, right? Like these are all things that you think about. And I guess understanding some things about physics helps too, because if you understand physics, you can go and say, I want it to look realistic. But ultimately, it becomes a game of probability. And hopefully, if someday you decide to design your own video game, maybe this will be useful. What else do we have here? Oh my gosh, it's a question that I was thinking about lately. How many simple math problems, like 6 divided by 2, can a normal computer do in a second? Okay, this is directly relevant to things I've been thinking about because I've been working on the servers for Novid. And Novid is our automatic anonymous contact tracing app to try to tell whether you have been around somebody else who may have been around somebody else who may have been around somebody else who just tested positive. Because I said so many of these around somebody else, around somebody else, around somebody else, you need to have a computer, a server, which can do a lot of calculations quickly. Now, if you want to know how fast a computer can do calculations, here's a rule of thumb. The computer's speed, if you buy a computer or if you look at the tags whenever you're buying a computer, the computer's speed is measured in GHz. Okay, GHz is how you measure a computer's speed, and the G stands for billion, and HZ is per second. So 1 GHz means 1 billion per second. So now a billion things per second, billion watts per second. So yeah. So I see some people are talking about gigahertz. It's nice to see that people are also paying attention and talking in the chat, right? It's a gigahertz, it's a billion a second, a billion watts. Well, it's a billion basic operations. And indeed, addition is one of these basic operations. So you could think of it, well, you asked division, but like, roughly speaking, okay, maybe it takes 2 operations to do one of those, maybe it takes a half of an operation to do one of those, but it's the order of magnitude that matters. And so the way to think of it is you can basically do about a billion simple arithmetic calculations per second. And that's powerful, because if you think about that, you're like, well, the world only has 8 billion people, 7.7 or 7.8 billion people. And that means that if you need to do calculations for the whole world, like if the whole world was using Novid, at the same time, and I need to do some kind of calculations on the server to go and give some information to each person, the great thing is that the computer chip in the server is already operating with the same number of operations per second as the order of magnitude of the number of people in the world. This is amazing. This fact that a normal computer chip can do about the same amount of calculations as the whole world trying to do math at the same time, that's amazing. Now there's something else that's also important, by the way. If you are talking about computation, that's one thing. But there's another piece which is called memory. It's like if you're doing a computation, you often need to remember what you've been working on. And actually, that's one of the hard pieces of Novid. It's like, well, you have all of these people who have been with other people, so you now need to store this huge amount of information. It's like, how much information do you need to store? The good news is that if you could have like a gigabyte, oh, well, yes, you can have a gigabyte of memory. In fact, nowadays you can have a terabyte of memory. And the important thing to know is that this thing which is called RAM, RAM, RAM is something in your computer that your computer can access at speeds which are close to this like billion things per second. So basically your computer has an amazing power to do calculations which are on the scale of the entire human population. It can store things like the size of the whole human population inside its RAM. and its RAM is connected to its central processing unit, the CPU, by pathways that allow you to exchange information at these billions of operations per second, transactions per second. And each one of them can be computed with billions per second. And finally, the way that the information is shared back home, sent back over the internet, it's at gigabits per second. Basically, everything is in G. The fact that all the units are Gs mean that you can actually have one computer do a huge amount of work that can help the whole world. And that is actually why I eventually started Novid. Because what I said is, I see that if we make this app and have people use it, then from the server side, we can actually use all these observations about Gs so that we don't have to have like 1,000 servers in order to serve everyone in the world. We might not go bankrupt. Okay, I hope that was an interesting answer to your question. What else do we have? Okay, so Winter Rain, I saw that you asked a question about opposite angles in a cyclic quadrilateral adding up to 180. That's actually the topic of one of my daily challenge geometry courses, so I won't go deep into that here. I'll just give you a hint. Draw the point in the center and connect that point in the center to two opposite corners of that cyclic quadrilateral and try to use some things you know about angles and central angles. That's all I'll say there. Other things. So I see that somebody asked about Conway's Game of Life. We talked about that last time. So I recommend that if you're interested in that, if the live stream is still available, take a peek. Otherwise, you can find like lots of Game of Life simulators online. So I see that somebody has asked like an inequality. Actually, it looks like the inequality is a bit too complicated for the algebra and geometry audience. I'm sorry. It's the one about the square root AB, square root BC, and so on. But we're going to try to focus here at a level that people who are taking basic algebra or geometry can understand. Okay, so I see that somebody, Oh, that's kind of interesting. Why is statistics important in life? I like that one. Okay, why is statistics important in life? Well, what would you do if there were no statistics? Then, if there were no statistics, all you could do is you could say, I don't know, is it going to be likely to rain tomorrow? I have no idea. Like, if you have no idea of statistics or probability, you actually have a lot of difficulty making a prediction. Or here's another example. Statistics can help you try to figure out, for example, what percentage of people have COVID-19 right now. I think that's a very important question that people need to know in order to make a decision on whether we open up the country or open up your country in the next week, 2 weeks, 3 weeks. So statistics is something that lets us make decisions when there's like lots and lots of information that I need to look across. As one example of something that makes statistics, that makes it clear why you need to have this kind of big scale statistics, is that, I'll tell you something. I mean, this is something which I've also been thinking about recently. As you may know, there are other anonymous contact tracing apps out there. There are actually apps that you can get which will use what's called the Bluetooth signal strength to figure out how far away other people are. So what does this mean? So now the point is you have a phone, your phone has Bluetooth, and other people's phones have Bluetooth. And some people came up with the following brilliant idea. It's actually a very good idea, where as you're walking around, your phone goes and sees like how many other phones are nearby and what signal are they giving to my phone? Like how loud is the signal? Well, if you do this sort of works. You can find out if other people are nearby, but there's a big problem. And the big problem is that even though on my phone I sense that there's some really loud phone over there which is broadcasting a big signal, I have no idea if that phone just naturally always broadcasts a big signal. If it always broadcasts a big signal, well then that doesn't mean it's close to me. That just means it's a loudmouth, and it just happens to be really loud and also really far. So there's this need to go and try to figure out, what are the signals that different phones broadcast at? And this is a fundamental need for all of those apps which are using Bluetooth only. As you may know, Novid uses ultrasound in addition to Bluetooth, so we can circumvent that problem. However, it's still an interesting problem in itself. And if you wanted to try to figure out, like, all right, somebody out there has an iPhone 8, and the iPhone 8 is broadcasting to us. I want to know what kind of signal is it broadcasting. Well, I would need to do some statistics. I would need to know, typically, an iPhone 8, typically what signal strength does it broadcast at? But that's not enough. You see, it actually turns out that I was watching an online mini conference yesterday, which was hosted by MIT, and there were some professional researchers who work on Bluetooth who said things like, actually, the signal that you'll get from a Bluetooth device depends not only on the iPhone 8. Oh no, iPhone 8 is selling now. Okay, I mean, honestly, even though it's not selling now, many people are still using it. So I actually said the iPhone 8 because many people in the world, including me, use phones that aren't new. And so we need to make sure that we, actually, I shouldn't just say many people, I would almost say the majority of people use phones that are not new, right? So now the point is that if you have this iPhone 8, which is broadcasting to you, your statistics could maybe go and tell you, your statistics could tell you, like, what does the iPhone 8 typically broadcast at? But it's more complicated than that, because I was at this mini conference which was run online, run by MIT yesterday, and one of the researchers said it's not just that it's an iPhone 8. It also depends what angle the iPhone 8 is at, because the iPhone 8's Bluetooth transmitter radio is at a certain part of the iPhone. So you then need to also use statistics to go and say, well, if one of my variables is what kind of phone is it, the other variable should be what's my orientation of the phone. And then it becomes a tougher question of saying, when you have a phone which is in whatever orientation, what is its signal strength? Now, what makes this an interesting statistical problem? If the statistical problem was just, hey, what is the broadcast strength of an iPhone 8? That's easy to check. Just go into the world, get a lot of people's iPhone 8s, and figure out what is their broadcast signal strength. And you take the average. That's the simplest thing you could do for statistics. But now if I need to know both, it's an iPhone 8 and the angle. You cannot go and say, I go and take every possible different three-dimensional angle, and for each of those, I go and test all the iPhone 8s. First of all, there are infinitely many angles. So what I'm trying to say is, like, the task of saying what's the average broadcast strength of an iPhone 8, that's easy. You just go ask a lot of iPhone 8s. But if it's like, what's the strength for each different angle? Now there are infinitely many possibilities. And what statistics helps you do is it helps you to use only a finite number of those possibilities, just some of those angles, and from those some angles, you figure out enough information to guess what happens at the intermediate angles in the middle. So I hope that helped to explain, like, why this statistics is interesting. In fact, one of the most interesting things in the world is to go and try to figure out what's going on in the world if you don't have enough observations to go and see everything yourself. Let's see what we got here. More questions. Oh, okay. So somebody has asked a question about the base of the log. Why is it not possible that base of log is negative? And that is from Gagandeep Singh Parmar. Thank you very much for asking that question. So the base of the log, you see, some people here might not be familiar with logs, although judging from the fact that we consistently have about the same 200 people all the time, maybe you already know what logs are because you've been watching this live stream so much. But let me just translate that into a question that doesn't say the word log at all. You're basically asking the question, why is it not possible to solve equations like this? Well, of course it's possible. The answer is 2. Seems okay. This one seems okay. The answer seems to be 2. I think that seems reasonable. Why not? Right? I think that's quite reasonable. I think everyone here would agree that that's going to be 2. Minus 2 to the power 2 is 4. So that can be done. It gets more complicated, though, when you start to ask it in different ways. And when I say ask it in different ways, I think what I'm referring to is that, what if I have something that isn't like a nice number, right? Suppose I had minus 2 to the power x is equal to 8. What is this? So if you gave me minus 8, I could do it. Well, let's do minus 8. If I do minus 8, what's x? That's not bad. Tell me. I want to let people answer into the chat. What is the answer for x if I need minus 2 to the power x equals minus 8? That's reasonable. I mean, somehow if I want that, I can have 3. Like if I take something cubed, that will work just fine. So this seems quite okay. The only problem becomes, like, notice that the sign changed from plus to minus when I had 2 and when I had 3. Oh, looks like I have a phone call. I'm going to not take that one right now. I should probably have silenced my phone. Just a second. So one of the issues right now, as if you saw in my earlier live stream of my class to the Carnegie Mellon, because of Novid, occasionally there are people who are calling because of something. I mean, we actually just made a media release today, but they will wait for you guys. So I'll talk to all of you first. So right, so I have this 4, I have this minus 8, and the issue here is that somehow the sign changed. And how often does that sign change? Well, it's pretty complicated. Like if you wanted to know what happens with minus 2 to some powers in between, although minus 2 to the power 2 was 4, and minus 2 to the power 3, minus 2 to the power 3 was minus 8. In between is weird. For example, what happens with minus 2 to the 2.5? Well, 2.5, that would be equal to minus 2 to the 2 times minus 2 to the half. Uh-oh. This is not good. The reason this is not good is because I got 4 times root 2 times I. So in fact, what happened is I just left the real numbers altogether. So the main problem is that you actually have a lot of issue deciding what to do if you had the minus 2 to these kinds of real numbers in between. And for example, minus 2, if I want to go to like 2 1/3, that would be actually okay, because I can actually maybe take the square root, the cube root of minus 1. You could maybe say that the cube root of minus 1 is minus 1. But the problem is that it's even more of an issue, because it's like there are actually 3 cube roots of minus 1. And which of the cube roots of minus 1 should you actually take? That's difficult. There are 3 cube roots of minus 1 because the other 2 cube roots of minus 1 are imaginary numbers. So the bottom line is that when you have all of these fractional exponents of a negative number, it's actually not very easy to define what happens. So that's why you don't want to take the log base negative number of another number, because otherwise it's actually very hard to define in the first place. Whereas if I was taking log base positive numbers of another number, then I'm solving equations like 2 to the power x equals something. And 2 to the power x, it just does this. And at some point, it will go through every positive number. Okay, hopefully that was useful. What else do we have? Oh, okay. People still calling me. I'm going to take this one. I'm not going to take this call. I'm going to just say, this one's going to wait. This one's going to wait. Yeah, I mean, actually, right before this live stream, I had put out a post which was saying that because we have just cracked the code and found a way to use ultrasound to actually do this anonymous contact tracing, various newspapers or whatnot are now notified. But we'll hit that afterwards. I saw an interesting question about computer programming, which I think is pretty good. Can you explain something that's useful in math that's really useful in competitive programming? Or do you have any other tips regarding competitive programming? And this is from Luka Nedimovic. Thank you very much. Nice to meet you, Luka. I love competitive programming. And in fact, it's because of competitive programming that when it came time to write the Novid core algorithms, I actually did the programming myself, and it's written in C++. Now, if I wanted to give you some tips, the biggest tip I would give from math to competitive programming is what we just saw at the beginning about these gigabytes and gigahertz. The very first thing I like to do is whenever I look at a problem, I like to think, what is the order of magnitude? How much like memory do I need in order to pull something off? How much time do I need to pull something off? And if I can't fit within the time and memory specifications, then I don't use that algorithm. So that's number one. And number two is that whenever you can try to don't repeat the same work, that's good. There's actually something at the heart of the Novid algorithm when we're trying to find out who has been near who. If you just simply do it with every single person, you go crazy. Like if what you do is you say, all right, here's a person, who has this person seen recently? Or you go hunting through all of the data and go and see like through these gigabytes of data who I've seen recently. And then who have those people seen recently? And you look through all the data again. We'll finish at some point. And then we say, great, you just did that for this person. Here's another person, do it for them too. Then you have to do it all over again, and the algorithm is too slow. So the advice I would give is whenever you can find a way to not do the same thing twice, that's great. If you can ever go and say this particular piece of work, I could in fact do it once and then use the results a lot of times. That's one of the biggest tips in competitive programming. One of the biggest useful things in math that's useful in competitive programming, I would say, is an area of math called graph theory. Graph theory is the area of math that I specialize in nowadays, but it's just being able to think about, if I have a bunch of nodes and those nodes are connected to other nodes, are there any efficient algorithms that you can make on graphs in order to solve your problems? And to understand graph theory, if you understand graph theory, this helps you a lot when you do those kinds of questions. Other questions? Oh, okay. After you finish the AOPS pre-algebra books, would you recommend algebra only, algebra and geometry at the same time, or something else? Okay, So this is about the AOPS algebra books and the geometry books and the pre-algebra books. To be perfectly honest, I don't know enough about these books. I know the guy who started AOPS and I know the people who work there, and those are great people. But I actually don't know enough about their books. So I would just simply say resources are resources, they're valuable. I would look at them and decide what you want to do. My personal take on this, I mean, is that somehow I think that their books are indeed very comprehensive, and if you went through the whole book, you certainly know a lot of things. Maybe the way I personally learned math is a little bit different. I jumped around, and so I enjoyed going to different topics so that I wouldn't maybe spend only my time on algebra. So I think your question was, should you do algebra and geometry at the same time? I mean, the way that we choose to do it at the Daily Challenge for our online courses is that we actually every month switch between different topics. And the reason I think that's valuable is because I think it's better to actually see multiple different topics at the same time. So if you were choosing among books, I might suggest doing the same thing. I mean, if it's possible to kind of look at different ones at the same time, that's not bad. But that will, of course, depend on how the books are written. If the books are written in a way where the geometry one requires absolutely that you did the whole algebra one, then it won't work. And I don't know enough about the books to give you a very specific recommendation there. What else can we do? Meanwhile, I keep getting this call from California, but we'll put this aside. Yeah, I'm looking to see, there's a lot of different kinds of math questions. Oh, this is interesting. Twisting Gamer asks, how to tell if your friend is lying with math? Okay, that's an interesting one. If you want to tell if your friend is lying with math, I think you need to know what they're lying about. If they said some statement about where they were, that would be a question where you might use geometry. It's like if somebody said, 5 minutes ago, I was in Siberia. I'll say you're lying. I mean, unless they are somehow video calling me from Siberia, because somehow it takes a long time to get from Siberia, right? It's like if you were in Siberia 5 minutes ago, you're probably still in Siberia. And so I'm trying to say, like, somehow this is a distance thing, this is a time thing, right? So I would go and use some geometry there. There are other things where if it's almost like these crime scene things of the geometry of could the person have gotten out of the door in time or whatnot. That's a geometry question. Other things, I mean, you might try to use physics to understand. I guess that was also related to geometry. There are things that you might be able to use. Maybe you might be able to use number theory. If there's something that's alternating, if there's somebody who's somehow like walking in this way, and somehow you just notice that the footsteps are off in the sense that it's somehow skipped one of the footsteps. I'm just making stuff up. I'm just trying to say somehow you can use these different math concepts to notice that something weird happened, right? I'm basically saying you can use math to go and figure out something weird happened in the middle when you weren't watching. Oh yeah, here's the classic. Here's how you can tell if somebody was lying or if somebody was cheating. It's like, look, if somebody started here and then drove on a highway, and the highway has a speed limit that says 55 miles per hour, but 1 hour later, they were somewhere that was 80 miles away, well, you're actually guaranteed that somewhere in between, if you got from here to there, 80 miles, and you took only 1 hour to do so, then surely there has been a place somewhere in the middle that you were going over the speed limit. But we don't actually know where that is. We don't know if you were going over the speed limit in the beginning part, or in the end part, or throughout the whole thing. We just don't know where. However, we do know that at some point you were speeding in the middle. So I'm just basically showing that how like somehow the math lets you prove stuff. It lets you prove stuff way beyond reasonable doubt. And these are just a few examples. And hopefully you won't ever have to catch your friend lying in that way. And hopefully you won't be caught lying in that way either. Okay, what else do we have here? I see some complicated questions that have something to do with combinatorics, with like 18 teams, 12 teams, matches, 6 matches. Those are interesting questions, but unfortunately the topic of the audience, the target audience of this live stream is not at that particular level. Oh my gosh, this California still wants to call me. I'll have to call them back later. What else do we have here? Actually, it looks like that one was Connecticut. So it looks like somehow, yeah, something's bouncing around the world. Hopefully it's okay. All right. What else do we have here? Oh, okay, this looks cool. All right, so here's a question, and maybe everyone in the world, everyone who's watching can play with this one too. Eric F. Eric F asks 12.95 times 3.6. And the question is, how fast can you compute this? Everyone's welcome to try. I have an idea. I'll tell you what I would do. But I want to let you look at it first. Typing it into the calculator is not interesting, and please don't do that, because then that will spoil it for everyone who's trying to do it, right? Like there are some people who are trying to do this. So hopefully this looks interesting to people. 12.95 times 3.6. How do you do it fast? Let me tell you what I would do. I would say 12.95 is approximately 13. So this is 13 minus 0.05 times 3.6. There's a reason I'm doing this. It's because 12.95 is a long number. 13 is a short number. And if I do 13 times 3.6, 13. 6 is 9. 9, no, it's not 9. 3 times 6 is 18. And I'll tell you how I caught that. I know that was weird because I was like, 99? That can't be the right answer. 3 times 3 is 9. 10, that's much better. 108. And 3, 6. Hooray! Oops. Looks kind of ugly. 3, 6. All right. 8, 6, 4. 4, 6, 8. So this is 46.8 minus 0.05 times 3.6. The way I do 0.05 times 3.6 is I'll say it is 5 times, it's actually like 5 times 36 times 0.001. I'll have to move the decimal 3 places. 5 times 36 is okay, because 5 times anything is 10 times the thing divided by 2. 5 is 10 divided by 2. So I take the thing divided by 2, which is 18. 36 over 2 is 18, times 10 is 180. So I get 46.8 minus 180 times 0.001, which is here. Okay, we're done. 46.62. Are we good with this? Yes, we are. 46.62. That's the answer. Okay, now I want to talk a little bit about what we thought through as we were doing this. It's like there are lots of different ways to do this. You know, what if we had just done it the normal way? You could do that too. 12.95 times 33.6 is like 30. 6 times 54. 54 plus 3 is 57, I think. 12, 17, 7. What? Really? Is it that beautiful? I actually think that's cute. Now I'm curious. Is it really 7770 or did I make a mistake? This looks fishy. 6 times 2 is 12. 6 times, oh, just a second. Or is that actually right? Please help. You guys know how to do arithmetic better than I do. 6 times 5 is 30. 6 times 9 is 54. Plus 3 is 57. 6 times 2 is 12. Plus 5 is 17. 6 times 1 is 6. Looks legit. Okay, looks legit. You know, I think that's really pretty. When I see 7770, I'm just like, oh, that's neat. It has a 111 as a factor. 111 is 37 times 3. So what that means is 1295 is a multiple of 37. I think that's kind of cute. Okay, let's keep going. 3 times 5 is 15. 3 times 9 is 27, 28. Oh, that's a 2 up there. I ran out of space. 3 times 2 is 6, plus 2 is, again, 8? 7, yeah, okay, 8. And 3 times 1 is 3. Okay, 0, 12, 16, 16, 4. Move decimal 3 places. Okay, it agrees. It's right. Okay. It's weird to multiply right to left. I mean, people are saying, you know, like, how are we doing this? Now, let me tell you a little bit about why I did it this way versus that way. When I was doing this, you notice that as I wrote stuff down, I would say, is that right? Because it's far too easy when you're doing this kind of calculation to just kind of multiply wrong or add wrong. So every time I look at an answer, I even think about the prime factorization of what I've built. So like 7770, I was like, okay, it's got a 5 in it. That's good. That makes sense. I multiplied by a number ending in 5. It has 777, which is 7 times 3 times 37. And I can see a 3 from the 6 I was multiplying, and I was like, okay, I guess there's a 37. But as you add, you're always like, did I forget to carry or did I not forget to carry? I find it scary. Over here, I said 13 times 36. 13 is a small number. I surely won't make a big mistake with that. And the 0.05, the reason I was excited with the 0.05 is I said, I know how to multiply by 5. You divide the other number by 2 and you multiply by 10. And so I said, I think I can do it this way. Okay, so I hope this was a way to show how you can do these kinds of calculations. I don't know if you had a better way in mind. I mean, it's quite possible, but this is just what I did. Hmm. Oh, interesting. Sophie Zhang asks, is it normal to get bad grades when you're good at math? It happens to some people, so I don't actually highly encourage it, but it does happen to some people because maybe they find it boring. I mean, maybe they find that the kind of math that they're doing is like this, and you do this and you get it wrong, and once you get it wrong, you lose points. So unfortunately, that causes a bad grade. My advice is don't do that. I mean, my advice is like, yes, even if something to you is boring, at least figure out how to do it efficiently. Even when I was doing this, which is otherwise normally a boring thing, you can see in my head, I was always like, did I learn anything new about prime factorizations? Have I found any neat ways to combine numbers together? And I'm like, wow, that's really cute. 7770? Really? Like I didn't expect that to pop out, right? So you can go and take some pride in all of these things that you do, and then hopefully you'll get also better grades in math. So my suggestion is like, grades, you should get good grades. You should respect your teachers. Someone gave you a task to do a good job with the task, and you'll get good grades too. But then don't satisfy yourself with just that. You're obviously the kind of people to be watching this live stream, and what that means is you're probably not just looking for grades, because I'm not giving you any points. All I'm giving you is like random crazy math problems, and you guys get to type all kinds of things in the chat. Dayit asks, is it okay to get a B in school? Question mark, question mark, question mark, question mark, question mark. Well, again, this is a matter of like what you want to motivate yourself to do. My point is, if you want to get good grades in school, that's a mentality. You set the mind to it, and you can. I mean, you set your mind to it, you make sure you organize your time appropriately, and you can. So preferably don't. But if you do, it's not like you're terrible. I mean, like, to me, the grades are just grades in school. But ultimately, what really matters is what you can do eventually. So my bottom line is like, it's basically this. Try to do the best to get the grades that you can get. Get good grades. But don't satisfy yourself by just getting those grades. Those are just grades. Those are just some things written on paper. There are plenty of people who didn't get good grades who do amazing things afterwards. There are also plenty of people who did get good grades who do amazing things afterwards. But there are also plenty of people who got good grades and did nothing afterwards. Don't be one of those people. What matters is to kind of figure everything out. Okay? So that would be my advice. What else can we do? Let's hit one more question. We have 2 questions about boredom. Looks like Carbon News asked, what do I do if I'm bored? And Eric F was even more specific. What do I do if I'm bored in math class at school? Here's my suggestion. If you're bored in math class at school, or if you're bored in any class at school, you can still learn something about how people present stuff. You see, I'm going to share a little piece of detail about what I do these days in life. I was involved in coming up with some of the most important technologies that make Novid do what it does. But that's not enough. It's actually not enough just to say you did what you were supposed to do in school. We're not done. I'm still stuck. You can't download it. What are we doing now? What we're trying to do now is to figure out how to communicate with people. In fact, that's why I've now, in the last 24 hours, been working on like public communication or media or like press releases and so on. Why am I talking about this now? It's because the place that I learned a lot about this was actually by watching my teachers explain things. It's like, you might already know the stuff. You might consider it boring. But it's very interesting to try to watch someone attempt to say something that you fully understand already to people who don't yet understand it. And if you can learn something about how that's done, then you'll also be more effective later on. So when I was in math class at school, I would actually always pay attention. I was like, this is interesting. Go and see what people are saying, how they explain things, how the teachers explain things. Think to myself what I might do. And then afterwards, I'll do some problems in the room because everyone does some problems at their desk. And then I'll start explaining to people around me in a way that wasn't annoying. And if you do it in a way that's not annoying, everyone gets along. It's actually a lot of fun. I really enjoyed going to math classes, even if that math class was something that I knew, because I knew it would be a chance to kind of have time to help people and maybe even learn how to explain something better. You don't actually have to be bored, right? It's not that long that you're there. And if your brain is active, you're often thinking like, yeah, I just heard this. And that's an interesting angle that I hadn't thought of before. Okay. All right. Well, Unfortunately, we have hit the end of time. I know that I didn't start exactly on time today either. That's because of these crazy things that are going on with Novid right now. But judging from the fact that my phone just rang 3 times with numbers coming from different states, I probably need to go and figure that out. Because one of my top priorities right now is to try to make it so that when the country reopens here in the United States within the next 3 to 4 weeks, my goal is to make it so that when the country reopens, we don't immediately have this explosion of COVID-19 that causes us all to have to go and shut down again. So I'm going to go and move into that other sector of my life now. But tomorrow we'll still be back. Tomorrow it will be 8 o'clock p.m., the weekend live stream. I encourage all of you to come. And I will, again, emphasize again, please, if you know anyone who thinks this is potentially interesting, please share this with them. Because, this is a chance to have this fun chatting with all of these people here on math, while also, having some bit of a social outlet in this time when we are all stuck at home. See you tomorrow.